everyone, welcome to another LeetCode session. Today we are doing binary search iterator. This is a very popular question, mostly asked in Facebook on-site interviews. So what a binary search tree iterator is, in this particular case, it is a in-order binary search tree iterator, but you can have a pre-order or a post-order binary tree iterator as well. So what an in-order iterator will look like is just your in-order traversal. So in order we go left, then we print the value, then we go right. So for example, in this binary tree, you would print 3, so your recursion would go left, you would print 3, then there's nothing on the right, so your recursion unfolds, then you print 7, then you go right, but then your recursion would continue, so you would not print 15, you would go left, keep going left, so you print 9, then the recursion goes to the right, there's nothing on the right, so the recursion unfolds, you print 15 and 20 and so on. So if we really think about creating this, so in order traversal recursively is very trivial, right? You just go left, print, and you go right. But if you want to think of an iterative way to do an in-order traversal, you might want to think of what exactly are we doing. So firstly, we are going left as far as we can. And then as your recursion unfolds, you're taking each of those values, right? So what is a good data structure to keep those intermediary nodes and then pop those values when we need them? So a good candidate would be stack. So let's say if we have a stack here, we could push 7 and then we could push 3, and then since there is nothing in the left of 3, we can then pop, and that would be our first value, right? Now if you think, let's say in this example, if 3 had a right child, so let's say if 3 had a right child as 10, then that would be the next candidate. So what you want to do is after you pop, the next available root or the next available node would be the right of the node you just popped, right? So in this case, 3 does not have a right child, but just assume that 3 is a right child. So in that case, you would traverse right and then carry the whole process. So what I want to do is, first of all, your iterator should know the root of the tree, because that information should be known to you, because that's where you would start, right? So you would have a root and you would initialize that when you would initialize this iterator. And you also want a stack, and that should be of type TreeNode. So in your next, what you want to do is, and we can assume that next is called only when there is a valid value. So you don't have to worry about any exceptions in this particular question. But if you're facing this in an interview, then it's worth talking about what happens if you have a next which is called on an invalid node, or next is called without checking hasNext. So the first thing you want to do is you want to make sure you keep going left, right? So until your root is null, you keep going left and you keep pushing in the stack. And this is equivalent to going left recursively. Now, once you're done, so once there are no more values to the left of root, you will exit this loop, and that would be your first value. So you want to make sure you have a reference for that value. And the way you would do that is you would pop that. And now the next available root would be the right child of the value you just popped. So it is possible that there is no right child. For example, in this case we saw earlier, there is no right child, but imagine if there is something. So that right child would be the next available root. So I'm gonna do this. And then the next time you call it, the whole process just repeats again. But for this particular call, you want to return the value of this node you captured. And hasNext would be, so if you think about hasNext, you want to, what do you want to check? You want to make sure that your stack should never be empty. So either there is something on your stack. So let's say you only have one node. In that case, you want to make sure that your stack is never empty, and you want to make sure that your root is never null. I'm not sure about the second condition, because if you're only checking the stack is never empty, um, that should suffice. So, well, not really, because then you also, yeah, so you should check for both conditions actually. So you should check for if your stack is non-empty, or your root is null. Is not equal to null. Because it is possible that you have something like 3 and then you have 2 on, which is the right child of 3. So you add this in the stack and then you pop this, right? And now the next root becomes 2. So now your stack is empty, but you still have a valid value. So you want to check both the conditions, right? So let's try to run this. So it's accepted. All right, so this looks like an easy question, but it might be tricky to think about this in iterative fashion. Um, Feel free to subscribe to this channel and like this video. I will be posting an entire series on hard questions and for interviews later this week. So please make sure to subscribe. Thank you.